and they're hand sewn by Jean and her team.
The amount of hand sewing we did on the shuttle would absolutely amaze you. I've been a quilter, I've been sewing since I was 7, and I'm 69, so that's a long time sewing. The one thing I find so fascinating about it, though, it's been something that's been around, a technique and skill for over 3,000 years, and yet that's exactly what we need. Now, people ask us all the time, why do you need to sew by hand? Well, some of the fabrics that we use are too fragile. It's primarily the thread. Would you believe me if I told you we had a thread that melted at 3,250 degrees? We would joke it was a thread you could never get at Joann's.
Mom probably tried, though.
It was called AB440, AB standing for aluminum borosilica, which happens to be the same name of the glaze that we put on our shuttle tiles, which gives you a clue it's going to be a high temp thread. Now in our world, if we had a fabric or thread that was dyed neon pink, maybe a little darker than that, we knew that was a high temperature fabric or thread. If you're wondering why we would have in that area, primarily that thread absolutely had to be done by hand. It's probably, I would say, at least 5 times the thickness of a regular thread, kind of coarse to feel, and you would think, oh wow, a high temperature thread, it's a really super duper thread. If anything, we find the higher you go thermatically, it actually makes it more fragile, because I could not put a thread like that in a bobbin. It's just the fact it would go around and be enough to fray it. And if I'm sewing thermal barriers, which is another thing that we did by hand, those are 4.5 feet long, and they line the wheel well doors, all 3 wheel wells, and we built 12 of those. Those are done completely by hand, and it took about 4.5 days to stitch by hand. Now they had a spring tube in them. I don't know if you're familiar. It's like a chainmail tube that we would put batting in it, and that the tubing would go down the length of it, and that allows us to squeeze the part, put it where it needs to go, and it kind of flexes open. Well, not only did it take us 4.5 days to do one, you have 12, and it took 2 of us 18 hours to stitch them in by hand. Now, we have 3 on each wheel well door, and I would have a curved needle. If we took our needle too deep, it would fray against that metal tube, which was frustrating enough. But the fact I could only stitch 1 inch, when the thread would get so thin it would fray. So I'd have to stop, not my part, not the thread, bury it. So in essence, you're stitching 1 inch, stop, stitching 1 inch, stop, stitching 1 inch for 4.5 feet, and that's just on 1. So again, 18 hours for 12, and that's just for 1 wheel well. They ask how often we had to change it. I say it's like a toasted marshmallow. People think it was the bottom of the shuttle that got the hottest on reentry. Absolutely not. If you had a chance, and you've seen Atlantis, I'm sure, if you see her nose, that's reinforced carbon-carbon, leading edges, reinforced carbon-carbon. That's considered a fabric, believe it or not. It starts off as graphite rayon, and in a process where we layer it, so just like fiberglass, leading edge of the wing, RCC is probably about that thick. Hard as a rock, though. I have a piece in my little kit that I do my little tours around. I can hit it like a hammer on the floor. Takes a lot of process. It's very expensive to make. It's a company in Texas that built it for us for shuttle. People would ask us, well, why didn't you use that all over the shuttle? It's a hell of a lot of expensive fabric, very, very expensive. We only needed it where we critically needed it. The second hottest area is on the leading edge of her wing, as we call it, in the wing glove, right in there of her glove. That's the second. And unfortunately, when we lost Columbia, we have 22 panels on each wing. 6, 7, and 8 are the second most hottest on reentry. Panel 8 was the one that had the punch. So when we found out what was the area, we have our lead engineer for TPS. She was able to track the melted splatters of aluminum, and she alone was able to figure out exactly where the path of the debris hit and how we had not lowered it down to 8. Thermal protection, obviously. I worked at the Thermal Protection Systems facility, back shop as they call it back here. Our nicknames were the Sew Sisters, which is why I have a book called Sew Sister for Kids. But again, getting back to the thermal barriers, if they turned a light brown, we knew it was time to replace them. They generally flew about 3 times. And we have a piece of shim plastic that's even thinner than that clear plastic there. And here I am sewing thermal barriers in. Quality's coming up and down. They take a piece of shim plastic that's literally, I would say, the equivalent of maybe 3 pieces of paper. So as we're shutting the leading edge door, any door, they stick a piece of shim plastic between it. And if they can move that plastic we have to put the thermal barriers and adjust them again. We want it where that door is so tight fitting, nothing moves. So the actual hottest area on reentry, you got to remember, if you see the nose, there's a curved panel. It's about this big, about this high. We call that the shuttle smile. It's called the chin panel. That is the absolute hottest area on her. So consequently, we built a blanket by hand in there too. Chin panel blanket, so obvious. It also had a spring tube all the way around it. So after we stitched it, we would compress that blanket down, stick it in, it would pop up, and then we would hand sew it all the way around. That was tricky because it had a beveled edge all the way around. So that was tricky there. We built gap fillers between each of the tile, thousands of those. Those are all done by hand. So if you see white spaces between the tile, for anybody who sews, instead of interfacing, we had a foil called Inconel. And if I'm interrupting,
They're just giving updates.
okay, so we had Inconel foil that we would put as our interfacing. We had to know mathematics, that was pretty given, because we had to measure out grams of batting for every part that we built.
For small satellites that are.
So like we had 5 different densities of tile. We had 9, 12, 15, 18, and 22 pound. They don't weigh that. We're talking density as we're building it. Still building them at the building, by the way. We build them for a couple of companies, even now. So if I'm doing a gap filler and I need to know how many grams of batting to put into it, it depends on what tile I was putting it in between. If I've been putting it between 2 9s, I have the same amount of grams that I need for it. But if I'm putting a gap filler between a 9-pound tile and a 12, what's my calculations? I have to add how many grams of 9 would it be, how many of 12, add it together and divide it by 2. So that's how I knew how many grams of batting to go into that one little gap filler. Some of our gap fillers are about this big and some were this big, because every square inch of her had to have thermal protection. The gap fillers serve not only heat protection between the tiles, but as we're sticking them between the tiles, the sidewalls of the tile, it was like padding. So as the shuttle's coming home and the tiles are vibrating, the gap fillers would also act as little padding that we had. But I think one of the things I really love talking about, the front end of the shuttle's cool, but I thought the back end was the neatest. If you notice, the shuttle had giant rings around her, the dome heat shield blankets. Biggest blankets we built for shuttle, 8.5 feet across. Took us about 4 to 5 days because those are done by machine and by hand. We had a 1914 Singer sewing machine, and that shocks everybody because we had 3 of them that were built between 1914 and 1917. For people who don't sew, what's the big deal? Well, nowadays most sewing machines are plastic parts or plastic. All of our machines were heavy-duty, strong machines. We kept an NASA tradition by naming all of them. That started back in the 60s with the Apollo astronauts with Big Mo and Sweet Sue, that they named their Singer sewing machines that built the space suits. Notice how I say built. We don't say sew. We're manufacturing, so we say we don't sew. We build our parts, or we built this. So we kept up the tradition in our building. So the machine I always talk about when I do my talks is Lurch. Lurch was the oldest one, and he started off this big, and we cut a section of him out and extended him out to be almost 7 feet long. So he's the machine that we would use to quilt the blankets. It's like an arrow, like a sunrise of half circle, but they're radiating out with 125 rows of stitching. So I have to hand knot and bury my dot in each one. We had a 4-inch ceramic sleeving, like a bias tape, that would finish off the inner and outer edge. So those are done by machine and by hand, but it's installation that shocks everybody. Can anybody imagine how we installed them on the Space Shuttle? We hand sewed those onto the back of the shuttle with an Inconel wire thread. Now people ask me, hey Gene, do you climb up there and sew? Heck no. No. So what we do is, there's actually a structure underneath each of the blankets, and so we would take that whole section down. We had a circular table that we would put the Wright framework on, lay the blanket on, and again, taking my little 2-inch curved needle. Some ladies use 4, but I like to use a 2. And with our wire thread, hand sew all the way around, and it would take 2 of us about 8 hours to put finish the engine blanket. All the thrusters were done by hand, believe it or not. We had a wooden structure that we would put our fabric in and hand sew it around, and so those were done by hand, just for numbers. The blankets on the outside of the shuttle, we started flying those back in '88. We did test blankets beginning with Challenger on STS-6, She had test blankets all over her. When we found out it was feasible, unfortunately, when we lost her, we put Columbia in Bay 2, retrofitted her with just like the rest of the shuttles were, took off almost 7,000 white tile off of Columbia, changed it with blankets, and we saved almost 7,000 pounds. I can show you, they're called production unit. We only have 2 sewing machines in the United States that quilted the blankets. One's in California, we have one in Kennedy. I wish you guys could get a tour of our building, it's so cool. The machine is 10 feet tall, it looks like a quilting loom. Has 30 needles, they're 9 inches long, 3 gallons of WD-40 that we would have to put in the trough, and it took about 3.5 minutes for it to quilt one way of a 30 by 30 inch piece of fabric. We made those in 11 classes of thicknesses, as thin as a placemat to 2 inches thick, and the range that the blankets could do was the exact temperature the tile could do. Now, I could pick up a blanket and it weighs a ton compared to a tile, but you gotta remember, if I have 30 by 30 inches a piece of fabric to work with, depending on the size of the tile, I can fit anywhere between 10 and 25 tile in just that one piece of fabric. It's very complicated to make some of our tile. Some of them have curved edges, beveled edges. We have really simple ones, but some are very complicated. So it's actually just cheaper for us. And the beauty of that is, if you remember how tight the ohms pod was, for us to fit a tile there was a bear. We had to do what we call the dice cut, cutting a tic-tac-toe design on the back of them to get the inner curvature that we needed. And I can take a piece of flexible fabric. Those are class 11s, those are our thicker blankets. And we just bend it and we've got that nice curve. Now people think, oh, the blankets are so thick because it's by the engines. No, because the ohms pod were composite material. NASA requires us not to have the skin on the shuttle get hotter than 350 degrees. That's why the blankets were so thick. And everything's glued on. We had a glue called room temperature vulcanization. Tiles were glued on, blankets were glued on. If we had a part that frayed, we would use that. So again, a lot of hand sewing. The blankets, if you're curious, people will look at Atlantis the first time and say to me, that's not the real space shuttle. And I'll say, why would you say that? You notice how she was modeled different colors. It's not completely pure white. Of course, some of that's re-entry, but after we make the blanket and reshape what it's going to be, all 2200 are hand knotted all the way around. We flip the fabric to the back, what shape it's going to be, and all of them are hand sewn all the way around. They get sent across the street for a pre-check to see if they're going to fit the cavity they're going to go to, comes back to us in our building, and then we heat clean the blanket at 650 degrees for 4 hours, 850 degrees for 2 more hours. And there's a couple reasons for that. When I'm building that part, I don't have to wear gloves, and I don't like to sew with, I never use a thimble, couldn't stand to use that. But it takes out our oils from our body. But the key thing is there's sizing. It pumps up fibers when a fabric's being woven, so we want that out of the fabric. Because when we glue the blanket on, we want to be able to put our 2 coats of ceramic coating on it, and we want it to suck right into the fabric, and that's what it does. And I don't know if anybody sews, but the first time I was asked to do the tension on that machine, it took me an hour, because I wanted it just so, and it looked perfect. It was perfect, even tension on the back. So quality comes up to me and says, Jean, you're going to have to...